Converting decimals to fractions. So, as you can see on the screen here is my anchor chart. I apologize, I've never done one before. I looked at some, but I hope that this isn't too much or not enough. Anyway, I'm gonna zoom in so I can discuss some strategies and whatnot that I went through. So. All right, so I started with converting decimals to fractions. And I started with terminating decimals, and an example is 0.625. Terminating decimals are just decimals that, like the words, like it says, they end. They have an ending point. So the first step that I listed, I kind of went like a mathematical approach. I didn't do a model or I didn't use models or manipulatives, but I could have. But I was thinking more along the lines of 7th grade might, I don't know, be too beyond that, but who knows. For the first step to figure out for the terminating ones, you would divide the decimal by 1, which essentially basically gives you a fraction, but it doesn't because you can't have a fraction with a decimal on the top line. So right now it's just a division problem. So step 2, you need to multiply the top and the bottom by a multiple of 10 that corresponds to the furthest place value to the right. So the idea is to move the decimal in this decimal point in this decimal all the way over to the right here, so that it's no longer a decimal. So in the case here, that 5, the third digit, is in the thousandths place. So you would multiply both top and bottom by 1,000. Now, and we know that we're not changing the number here because 1,000 divided by 1,000 is 1. So by doing this, you end up with 625 over 1,000, which is also a 625 thousandths. So the third step would be to simplify that fraction down to, and that simplifies all the way down to 5/8. So that's the process I use there. So the next part I did was I went into repeating non-terminating decimals. So the example I'm going to be using is 0.414141, repeating. So the first step here, I chose to do the algebraic route. So you would assign a variable. So you're going to, x equals your decimal. Then the next step, so what you're going to do there is you're going to multiply both sides of this decimal so that, kind of similar to what we did in the previous with the terminating ones, you want to move this decimal point all the way over to the other side of the repeating section, which is 4,1. So you want to move this to the right 2 places. In order to do that, you need to multiply that number by 100. So since you have to do both sides of the equation, you multiply both sides by 100. So that gives us 100x equals 41.41 repeating. So now, then the third step to do here is to take the equation we just made and subtract that very original equation, the x equals 0.4141. So, and by doing that, you end up with 100x minus x, which is 99x, equals, and then you have 41.41 repeating minus 0.41 repeating equals 41. So your fraction here is actually 41/99. You can't simplify that down any further. So then I just put on my thing here some common ones worth remembering or considering. When it's 0.3 repeating, we know that that's 1/3. But I did the math. I did the algebraic method that I just did on this particular, on the 0.41 repeating one, and I end up with getting 1/3 right here. So if you can follow along, I took this one times 10 because I only needed to move the decimal one place. So I got 10x equals 3.3 repeating. And then 10x minus x is 9x. And then 3.3 repeating minus 3 repeating is 3. So 9x equals 3, x equals 1/3. So then I did another example here. I'm going to explain that one, but that is 2/3. So and then at the end, I touched on non-terminal and non-repeating, a non-terminal, non-repeating decimal. And essentially, a non-terminal and non-repeating decimal can't be written as a fraction. Those particular numbers are actually irrational numbers. So, well, they can't be represented by a fraction because essentially a rational number is, the definition of an irrational number is a number that cannot be represented as a ratio of two integers. So some examples are pi, square root of 2, square root of 3. There's several examples. In fact, I think I read that somewhere that there's actually more irrational numbers out there than there are rational numbers. So anyway, thanks for listening.